So the fundamental theorem of algebra talks about a polynomial having the same number of roots. The roots may be real, complex, which means imaginary, or irrational. And to find them, we know that we're looking for 3. So the fundamental theorem of algebra states that we know since our highest power is 3, we're going to have 3 roots. So what degree is this polynomial? The degree is 3. Let me get a pen here. Is 3. So how many zeros, both real and complex, should this polynomial have? It should have a total of 3. So going back to our rational roots theorem, where we get the p's and the q's, we can then find our possible rational roots. So remember, p over q gets us all possible rational roots. Our p is our negative 36, or 36 we can use because the negative is going to be there anyway. And then the q is 1. So since our denominator is 1, everything's going to be divided by 1, which just gives us all our factors of p. So remember that these could be positive or negative. So we have 1, 2, 3, 4, 6, 9, 12, 18, and 36. So those are all possible rational roots. So what we're going to do is we have to figure out which one of these is a 0. So 2 ways we could do that. We could put this in our graphing calculators and go to our table and figure out which one of these, when substituted in, gives us 0. Or we can go into Desmos and look at the graph. So if I click over here to Desmos, you can see that our 0 is right here. We click on it. So our rational 0 is 4. So we can come back to our paper and we can say that we know p of 4 is equal to 0. So we have 1 root. We're looking for 2 more, but they don't show up on the graph. They don't show up on the graph because they're probably complex. So to do this, we're going to use synthetic division. So we're going to use our 0, which is 4, to divide out a linear factor. So our original problem is, let's go back and get the coefficients, 1, 1, negative 4, 9, and negative 36. So we could then do some synthetic division to break this polynomial down to a quadratic. Our goal is to get a quadratic. So bring down the 1. 1 times 4 is 4. Add these together, we get 0. 0 times 4 is 0. Add, we get 9. 9 times 4 is 36. And remember, the last value in our synthetic division is always our remainder. Remainder is 0, which we want. This gives us our quadratic, 1 power less than our original polynomial. So we now have the equation 1x squared plus 0x plus 9. And we can get our remaining 2 zeros by solving this quadratic. This is a sum of squares, so that means we're going to get 2 imaginary solutions. So we can subtract our 9, take the square root of negative 9, which then gets us our 2 zeros, which are positive 3i and also negative 3i. So again, we have 2 complex zeros, they're conjugates, and then we have our other 0, which is 4. So our 3 solutions, our 3 roots are 4, which is real, and complex. We have 3i, and we have a negative 3i.